This is Calc, or AP Calc, Lecture 1. And today's topic is limits by table. So we're going to understand, utilizing the tables, what this idea of a limit is. So what does it mean for a limit? What are the different notations that we have for a limit? It's very important foundation for calculus. And first off, let me start off in talking about algebra. So how is calculus different? Well, in algebra, you're more, if I give you a point such as a f of a, you're really just, worried about that singular point. So what happens at x equals a? That's what kind of you do in algebra. You're like, what happens at when x equals 5? Now that will be part of what we study, what is going on. But in calculus, we might have that same value a, f of a, and instead of us really focusing on that one singular value, a, we might be more worried about what happens around x equals a. So this is the very big difference between the two for calculus and algebra. In algebra, we're always just like, f of 3. Find f of 3. Boom. Plug it in. You're good. In calculus, we're going to be asking questions about, what are the properties that are happening at maybe still at x equals a, but we're going to be wondering about the properties. What does the graph look like? Is it increasing? Is it concave up? Is it concave down? We might be putting down stuff like, what is the limits, as we're going to do today. And these are notes. So there's two things that you can do today. So as we're doing this, and you're seeing, and today's I'm going to be very brief so that we can learn how to best support you. In a traditional class, yes, this is notes. You should be taking them down. It's going to be best to learn. You're learning that way. If taking notes remotely, though, is problematic, if you feel like you can't keep up, these notes will be posted into Google Classroom as a PDF. In addition, the lecture video of me talking while writing the notes, not your faces, will be posted onto Google Classroom as well. If you look on the assignment, it says lecture notes pending, lecture video pending, and that means that they're coming up later on. It might be by the end of the day, it might be like 3, 4 o'clock, because I teach quite a bit of classes in a row. So in regard to this question about around, we refer to this idea of limits. Approaching x equals a. So this word approaching is a word that we're going to use quite a bit in question. So the question that we were really going to pose in these first few days is, what is the output of the function approaching as we get closer and closer to a specified value of x, but not equal. So we're never going to actually, the purpose with limits is that we are approaching. So if I say, hey, we're going to approach 2, we're not actually equaling the value of 2. We're just going to get closer and closer and closer to the value of 2. That's the big focus, okay? Output, we're looking at the output, which you might think of like the Y values, for example. That's what we're gonna be looking at. We'll talk about the value. Sometimes the value that you plug in is the answer for the limit, but sometimes it is not. Limits at a point. The first thing that we're going to talk about is what we refer to as a one-sided limit. One-sided limit. And the idea here is that we are going to be approaching the x value from one side. Only one side. Okay. Now, there are two sides, right? So we can approach this from the left hand limit side, or we can approach this from the right hand limit, the right hand side. Let's say we want to approach the value of 2 from the left hand side. And let's say, you've done this before, you've made tables, x, f of x. And let's say we're going to get a value and we're going to find out what we get from the left hand side. So, for example, let's say I start at 1, okay? And I plug in the value 1, all right? And I want to get closer to 2. So I want to approach x equals 2. Approach, not equal. So I plug in 1, and I look at the output. And I'll talk about the output. And then I plug in something that's closer to 2. Let's try 1.9. Now, notice 1 is to the left. If I think about the number line, 1 is to the left of 2. Okay, so I start at 1. Now 1.9, which is closer? 1.99, which is even closer. 1.999, which is even closer. I'm just going to rewrite this table because it got a little bit closed up. I'm rewriting the same exact table, don't worry. X, f of x, 1, 1.9, 1.99, 1.999. If I plug in these values, let's say the first time I plug this in, I get 25. I plug in 1.9 and I get 29.8. I plug in 1.99 and I get 29.997. I plug in 1.999 and I get 29.9999999. Okay? This is what we refer to how we're thinking about as limit. So, what is the y value approaching? So, yeah, I heard it. 30. And 30 is the answer. So this 30 would be the answer. Now, when you do these, you might actually get 30 as an output. Okay, if I got the exact value 30, that might happen because if we go so many decimal places, it is. Or, hey, it might be actually equal to 30. You might get 30, 30, 30, 30 for every one of these answers. And if you get 30, 30, 30, 30 for all the answers, then the limit is still 30. It's just a horizontal line function. So that value is right there. So now, and I'm going to talk about, I'll do the little notation. Right-hand side. If I want to approach the function from the right-hand side, so I want to approach x equals 2 from the right. So I do a table, x, f of x, and what would I start with in my table if I'm trying to find a value close to 2 but not equal to 2 from the right-hand side? Give me a value. Type it in. I want to investigate this function. What x value can I evaluate this function for that is to the right of x equals 2? No wrong answer as long as the answers, you got a million answers that's possible that as long as they're to the right on the number line of x equals 2. 0 is not to the right of 2. 3. There you go. Any number that's to the right of 2. 3. Okay, and I plug in 3 and I get 48. Okay. You don't know what the function is right now, but that's what I get you. And when you do your homework, you won't know what the function is either. The idea is, at first, we just want to understand if we plug in values, how can we evaluate what this function's limit is going to be? All right, what value would I pick now? That's to the right of 2, but I'm going to get closer than I was before. 2.1. Perfect. 2.1. 2.1 is closer to 2, and we're approaching 2. We're getting closer to 2, and when I plug that in, I get a 30.5. Okay. What value am I going to investigate now? 2.11 is actually not closer to 2. So we got to think about it in terms of our decimal places. 2.11 would be greater than 2.1. So what value would be less than 2.1 but greater than 2? 2.01. And this type of thinking, and it's not, the number lines and decimal, that's a very good, important foundation that we're working on as well. 2.01. Okay, and I get a 30.008. Okay. Let's try one more. Maybe at this point, you should know what the limit's approaching, right? You don't have to probably go any extra values. I think looking at this, we're very confident, but we'll do one more. I want to make sure you understand her number line and 2.001. And that gives me 30.00001. And so y is approaching what? And you can always type this in too. You don't have to verbally. Y is approaching 30. Yeah, also 30. Now, they don't need to be approaching the same value. This part is very important for the next part. So, when talking about the left-hand limit, from this example over here, from the previous example, in terms of left-hand limit, the way we write this is the following. The limit, so LIM is short for limit, as x approaches 2 from the left-hand side. Okay? This means the limit as x approaches 2 from the left-hand side. That's what that little minus says. Of f of x is, and what did we say our answer is? 30. So the limit as x approaches 2 from the left hand side is 2, or is 30. Now I do want to say, when I say this is 30, this means that the y approaches 30 is what it also means. Okay, so when I say is 30, it's the same thing as saying that the output y is 30. Now is approaching 30. Following the previous example as well, for the right hand limit, we would say the limit lim, as x arrow, which means what? What does an arrow mean? Approaching. Yeah. Oh, I'm writing the word right now. Approaches to from the right hand side. We do a little plus. It's a subscript. It's above it. So if I didn't write it small enough, it's up in the numerator, like an exponent. Plus right hand side of the function f of x equals, and we also got 30. The limit as x approaches 2 from the right is 30. And notice I didn't say right hand side that second time. I just said from the right, which means the same idea. So that's what we mean by one-sided limits. And you'll see some examples in your homework where you're going to plug in the numbers yourself, and the computer, the site, will spit out the outputs for you. So you're like, oh, let me plug in this number. Let me plug in this number. Two-sided limits are also known as the limit. So whenever I say the limit, it means two-sided. It means talking about both sides. All right. So here's what the statement is. If the limit as x approaches some value, we'll call it a, from the left-hand side is equal the limit as x approaches that value, a in this case, a is 2 in this example, on the previous example, from the right-hand side of f of x, then the limit as x approaches a, notice that there's no minus or plus, of f of x, and this, this equals L. In this case, L was 30, is also equal to L. Else does not exist, which we will write as D and E. It's a very important piece. So if I ask you for the two-sided limit, basically here's what it means. If I ask you for the two-sided limit, or ask you for what is the limit, then you have to realize that, oh, I have to first find the left-hand limit, then I have to find the right-hand limit. I have to find, so it's one problem that actually is two, it's actually three problems. I have to do these first two problems. And this is something that happens in calculus a lot. In order to answer this question, you need to be able to answer the previous two questions. So in that example that we just did, from example, the limit as x approaches 2 from the left of f of x was 30. The limit the limit as x approaches 2 from the right-hand side of f of x was 30. Dot, dot, dot. And these three dots right here, because I'll use them, this means therefore. That's what those three little dots mean. Therefore, the limit as x approaches 2 of f of x equals 30. We also refer to this part up top, this piece right in here, we call this justifying, explaining, reasoning. So you don't have to write out in words, but without the pieces on top, I can't answer the parts on the bottom. Okay? limits at vertical asymptotes. So a vertical asymptote happens when, and we're going to go into graphs and on Friday and Monday, but a vertical asymptote might look something like this, right? So you've seen vertical asymptotes in your previous math courses, and the graph blows up. It gets really, really, really big. Okay. Let's say that this is the graph of y equals f of x. In this example, let's say that this value right here is, let's go with 4. So that's the x value 4. So this is the line x equals 4. So if I were to set up a table of x and f of x for this problem right here, if I put in 3, somebody give me a possible answer based on this graph that it'll give me. And there's millions of answers. 6. Boom. Okay, good. Okay. Do I know what the limit is right now? Do I know, if I didn't have the graph, would I know what the limit is right now? That's what we're trying to answer. The answer would be no. I don't know it. All right, give me another value. I'm trying to get closer to 4 from the left-hand side. Give me a value that's going to get closer to 4 from the left, where I'm at 3. So what number would I plug in? 3.1. Okay, we're going to get there slowly. I get 8. All right, again, another one. It worked. 3.1 worked. That was true. That was good. But we probably want to jump a little bit closer. 3.9. Bam. I get 58. Do I know what the limit is yet? Do I have an idea based on this table what the limit is yet? Probably not. Give me another one. 3.99. I get 1,356. Oh, now I pretty much got an idea. This graph is getting bigger and bigger and bigger. Does that make sense? So as such, this, if I went one more time, 3.999, I might get 1,000,000,000. I get a really big number. What we say about this graph, we say that the output is growing closer and closer to positive infinity. It's going to keep getting bigger. The output's going to get bigger and bigger and bigger and bigger. A million, a billion, a jillion, Google. So we would say that the limit as x approaches 4 from the left-hand side of f of x equals. Now, when I say equals, equals is not a correct word, right? It's approaching, but mathematically we write it as equals, but it says approaching. The function f of x is approaching what? What is it approaching in this example? Infinity, yep. And if you want to, you can put a little positive infinity. You can put a little plus sign in the front, but you don't need to have that plus sign. If you just write infinity, it's understood that it's positive infinity. But we have it. If I were to do the same thing from the left-hand side, so I want to know what is the limit as x approaches 4 from the right-hand side of f of x. What number would I start off by plugging in? Look at the number line. You'd pick a number to the right of 4 on the number line. 5. I plug in 5 and I get negative 36. Okay. Next value. I want to get closer to 4. 4.5, okay. I get negative 59. Next number.
4.01.
Perfect. 4.01. I get negative 1,902. And let's go one more.
4.001.
Perfect. Negative 1,000,000,000. So, what is my answer getting closer and closer to? Not infinity, close. Ah, yeah, the sign matters. So now we need to put that minus infinity. Okay, and we'll talk about what that looks like on a graph. Last problem. Last piece for today. In behavior, limits at infinity. Okay? So I want to know, let's say my graph, and like I said, we're going to study the graphs a little bit later on, but you can't see the graph, all right? You can't see what the graph looks like. But let's say the graph does this. Okay? That's what the graph looks like. You don't know that. And actually, I haven't even labeled the table either. So we want to find out what is happening over here and what is happening over here in regards to the x values. So as x approaches to the left-hand side. So for the left side, not the left-hand side, but the left side, we write this as the limit as x approaches negative infinity. Negative infinity means I'm looking to the very far left of my graph, okay? Of f of x equals. Now, if I do a table, x, f of x, I want to get more and more negative. So let's give me a negative number. -3. I plug in -3 and I get 1. Okay, I want to keep getting more and more negative. I want x to get more and more negative. Give me a value. -10. I get 1.5. All right, I want x to get more and more negative.
-1,000.
-1,000. 1.9999. I want x. Wait a minute. Do you think you know what x is approaching? Can you figure out what x is approaching on the left-hand side? 2. Good. What about this right-hand side? What about the right-hand side over here? How would I investigate what x is happening over there? Well, if I set up a table of x and f of x, what values would I plug in? Give me a very big, give me a number to the right side of the number line. 100. All right, you're going to start off big. Okay, well, that's good. We'll start off big. We start off 100 and we get -59. Or positive, sorry, positive 50. No, yeah, I was right. Why are you saying I was wrong? All right, I want to get more to the right. Even more. 1,000. I get -509. I want to get more to the right. I think we can kind of see what the limit's going to, but I want even more down to the right. 10,000. I get -99. And actually, my calculator ends up spitting this out. -9e 10, which means -9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what it means. Okay, that's what the e button means on your calculator, or if it shows up on it. So the limit as x approaches positive infinity of f of x is equal to, or is approaching, what is the y values approaching? I mean, you can see the graph and it kind of tells you, but if I look at those values, what are those values going towards?
Negative infinity.
Negative infinity. And that's today's lesson.